first example I'd like to do has to do with the product property of exponents. Before we do this problem, let's remind ourselves what the product property of exponents says. It says that if I have some x to the m power times some x to the n power, this is the same as x raised to the sum of m and n. So in each case here, it asks us to rewrite the product of powers as a single power. And we're going to do that using the product property of exponents. So let's look at a first. A says 2 to the third power times 2 to the fourth power. How can we combine these? Well, notice that x is the base here. This is like the x in our formula in the top right. And this 3 is like the m, this 4 is like the n. So what we know is that if we have the third power of 2 times the fourth power of 2, we can rewrite this as 2 to the power of the sum of 3 and 4. Or in other words, we can write this as 2 to the 3 plus 4, or 2 to the 7. Now we can compute that and figure out what that's equal to, but it only asks us to rewrite the product of powers as a single power. And you see here we've written this product of two powers as a single power. So we're done. Let's look at B now. B says x to the 12 times x to the 11. Very similarly, you can say the base is x as it is in the formula, and m is equal to 12 and n is equal to 11. In any case, we know that when we have a product of powers, we can just add their exponents. So we know this is equal to x to the 12 plus 11, or x to the 23. And we'd be done at that point. Again, we've rewritten the product of powers, of two powers, as a single power. Also, this is as simple as this expression would get. Let's look at our final example here. We have z squared times z cubed times z. So what do we see here? Well, we see a product of three powers. And using the product the product property of exponents, we can combine these first two and then this that product with this third factor here, or this third z here. Or we can also remember that multiplication is associative and commutative. And in the same way that exponents are just repeated multiplications, we can apply those properties of associativity and commutativity. In this case, that means for the product property of exponents, we can say that when we have the product of any number of the same base, we can just add all their exponents. Or in other words, we could say that this is z squared plus 1 plus 3. Sorry, z to the 2 plus 3 plus 1. Or z to the 6th power in this case. And again, you could have gone maybe like in between steps, and you could have said first that z squared and z cubed make z to the 5th, and then z to the 5th times z makes z to the 6th. In any case, don't forget that this z is kind of like z to the 1 power. So when you're combining or multiplying z with these other powers of z, make sure you add that exponent of 1. The next problem I'd like to talk about has to do with the power property of exponents. So before we do this problem, let's remind ourselves what the power property of exponent says. It says that if I have some base, say x to the m power, and I take that power to the nth power, this is just equal to the product of powers, or to the power where the exponent is the product of these powers here. So again, what we're doing, we're taking powers of powers. And here you can say in the first case, we have 10 squared cubed, or the third power of 10 squared. Here we have t to the 4th cubed, or the 4th power of t cubed, or the third power of t to the 4th. You can say this a lot of different ways. In this last case, you can see we have a power of a power of a power. So it's layered twice there. In any case, let's read what this problem says and see how we can solve or answer this problem. It says, use the power property of exponents to simplify the expressions below. So let's start with 10 squared cubed. So 10 squared cubed, what can I rewrite that as? Well, using the power property of exponents, I know that if I have powers of powers, I can simplify this by multiplying their exponents. Or in other words, I could write that this is 10 to the 2 times 3 power, or 10 to the 6th power. Now 10 to the 6th power is just 1 million, so I'm going to simplify that. And let's go on to B. So B here we have the third power of t to the 4th. How can we simplify that? Again, using the power property of exponents, we simply need to multiply 4 and 3. So we have t to the 4 times 3, or t to the 12th power. That'll be our answer there. Now, again with C, we're going to apply the power property of exponents, but we're going to have to do it twice here. So remember the order of operations. It says to do grouping symbols first, in particular innermost grouping symbols. So let's start with innermost grouping symbols. We have these parentheses, x squared. Can that get any simpler? No, that's as simple as that gets. So let's look into the brackets. Now the brackets, we have x squared cubed. That is something we could simplify using the power property of exponents. Let's start there. So if we start there, we could rewrite this as x to the 2 times 3 power raised to the 4th power. Now, we can simplify this to be x to the 6th to the 4th. Now you see I changed from brackets to parentheses. That's okay. It doesn't really matter what grouping symbol you use as long as they're in the same place. And then finally, we want to again use the power property of exponents because we have a power, or the 4th power of x to the 6th. So we can rewrite that as x to the 6 times 4, or x to the 24th power. The next problem we will discuss has to do with the distributive property of exponents. To remind ourselves what that is, it says that if we have the product of two numbers and we raise that product to some power, we can distribute this exponent to both those parts of the product. Or in this case, if we had the product of x and y raised to the n power, we could rewrite that as x to the n times y to the n. So we're essentially distributing that power of n to both parts of our product. So let's look at this example here. It says use the distributive property of exponents to simplify the expressions below. So A, we have 7y squared. So rather than write 7y times 7y, what we could choose to do is use the distributive property to distribute this square, this power 2, to both parts of my product. So in my product I have this number part and this variable part, this y. So I'm going to distribute the 2 to the 7 and the 2 to the y, or this power of 2 to the 7 and this power of 2 to the y. So I could rewrite this as 7 squared times y squared. And if I simplify 7 squared to be 49, you can see I have a simplified answer of 49y squared. Let's look at B now. So B says take the 3rd power of s to the 6th t cubed. How can we do this? Well, again, see that we're going to use the distributive property of exponents. What is in our product? Well, in our product here, we have s to the 6th and a t cubed. And we're taking that product to the power 3. So we're going to distribute this power of 3 to the s to the 6th and this power of 3 to the t cubed. Notice when we do this, we're going to have to use the power property of exponents to get a final answer. See what I mean here? I'll distribute the 3rd power to s to the 6th, so I have s to the 6th cubed. And then I'm going to multiply that with t cubed, because I'm going to distribute that power 3 to both those parts. So, again, the power property of exponents will let us solve this problem and finish this problem, because we know that the 3rd power of s to the 6th is the same as s to the product of 6 and 3. We multiply that times t to the 3 times 3 power, again using the power property of exponents. So I'm going to write that right there. This is the power property of exponents. Power prop of exponents. And we can simplify this by simplifying our exponents to make this s to the 18, t to the 9, and we solve B. Let's look at C now. C, we have x to the 8th, y to the 9th, z to the 7th, all raised to the 4th power. So how is this problem a little bit harder or more difficult or different? Basically, this product now has 3 parts to it. It has x part, a y part, and a z part. So when we distribute this 4th power, we're going to distribute that 4th power to all 3 of those parts. Again, so we're going to take this 4th power to x to the 8th, we're going to take the 4th power of y to the 9th, and we're going to take the 4th power of z to the 7th. Let's start by rewriting that there. So we're going to have x to the 8th to the 4th, y to the 9th to the 4th, z to the 7th to the 4th. Again, we're going to have to use this power property of exponents to simplify the next step. We can write that the 4th power of x to the 8 is just x to the 8 times 4, and do similar things for the y and the z bases. So, see that this power property of exponents, this applies to both these lines. That's how we were able to make both those moves. Simplifying these exponents, we can write this as x to the 32, y to the 36, and z to the 28. And that will be our final solution there. The next problem I'd like to talk about has to do with the negative exponent property. The negative exponent property is really more a definition than a property, so let's write that up. It says if I have x to the negative n power, this is the same as 1 over x to the n, or 1 over x all raised to the nth power. So what is a negative exponent? A negative exponent kind of indicates a reciprocal or a multiplicative inverse. So x to the negative n, we can think of that as the reciprocal of x to the n. And we know the reciprocal of x to the n is just 1 over x to the n. Let's look at this first problem. It says rewrite the expressions below with positive exponents only, then simplify. So 12 to the negative 2, this is like the reciprocal of 12 squared, or the multiplicative inverse of 12 squared. And the multiplicative inverse of 12 squared, or the reciprocal of 12 squared, is 1 divided by 12 squared. So if we have 1 divided by 12 squared, we could rewrite that as 1 over 144. And you see we've completed part 8 of this problem. So again, what have we done? We started with an expression with a negative exponent, rewritten that as an expression with a positive exponent, and then simplified that expression. In this case, if it wasn't totally clear what we were doing, we had a base raised to a negative exponent. Think about this base in the formula as x, this exponent in the formula, this negative 2 as n, and we can rewrite that in the way that we have and simplify in the way that we have. Let's look at part B now. So part B says 17x to the negative 3. So what's being taken to the negative third power? Notice only x is being taken to the negative third power. 17 is just making a product with whatever that quantity is there. So just for simplicity, or for clarity I should say, I'm going to rewrite this as 17 times x to the negative 3. So we know the negative 3 power is really only applying to the x. And we know that from this step here too, just so you guys know if you got confused. So what we can do here is we can rewrite this as 17 times 1 over x cubed. Now we did that using, again, the negative exponent property. We can think, what does x to the negative 3 mean? It means the reciprocal of x cubed, or the multiplicative inverse of x cubed, and that is 1 over x cubed. So now we've rewritten this with positive exponents. Let's simplify it, and we can simplify this just by multiplying to say that this is 17 over x cubed, and that'll be our solution there. Let's finally look at C. We have 1 over x to the negative 1 power. So again, let's go forward using the negative exponent property. We can say that this is 1 divided by, well, x to the negative 1. I know this is like the reciprocal of x to the 1, or the reciprocal of x. And that's 1 over x, or 1 over x to the 1. In any case, we could simplify this expression. We've written it now with positive exponents, but let's simplify it. We have a fraction of a fraction. So what we can think back to is what's the definition of a fraction or a quotient? It's division, right? So we can say this is 1 divided by 1 over x. And I know that division is the same as multiplication of reciprocals. This is the same as 1 times x over 1. And we know that 1 times x over 1 is just x. And we solved that problem here. So you'll notice a pattern when doing problems with negative exponents. Things that have negative exponents will change position in their numerator and your denominator. And you can see that in the case of all these here. We had 12 to the negative 2, so we're going to have 12 squared in the denominator. Again, 12 to the negative 2, this power is in the numerator, and it transitioned to be in the denominator. Similarly, we had x to the negative 3 in the numerator in part B, and it ended with an x cubed in the denominator. Part C, we have the opposite, where we started with a negative exponent in the denominator, and that negative exponent will end in the numerator. Just a little pattern to notice as you do these things. The next problem I'd like to discuss has to do with the quotient property of exponents. Before we do this problem, let's remind ourselves the quotient property of exponents. It says if I have the quotient of x to the m and x to the n, this is the same as x raised to the difference of m and n. Now we have a special stipulation here that x cannot equal 0. Why is that? Just because we can't divide by a 0. So we have this property here about the quotients of powers, and that if we have a quotient of powers, we can just subtract their exponents. So let's look at how we could use this in an example. This problem says simplify the expressions below using the quotient property of exponents. answers should be written with positive exponents only. So you'll see this stipulation a lot, answers written with positive exponents only. Just be aware of that when you're solving problems. So this problem here, we have 10 to the 104 divided by 10 to the 99. See, we have a quotient of powers, so we're going to subtract exponents. See that I could rewrite this using the quotient property of exponents as 10 to the 104 minus 99, or 10 to the 5 if I do a little simplification. Now 10 to the 5 is 100,000, so I'm going to put that there. I've simplified my solution, and I'm done. Let's look at part B. So again, we have a quotient of powers. We have the quotient of x to the 32 power and x to the 71 power. We're going to use the quotient property of exponents to rewrite this as x raised to the 32 minus 71. Again, x raised to the 32 minus 71. So again, we're just finding the difference of the numerator power and the denominator power. So 32 minus 71, that's going to be negative 39, so I have x to the negative 39. Now be aware, because of the second sentence in this problem, we're not quite done here. We need to rewrite this so it has positive exponents only. So what do we know x to the negative 39 is like? Well, x to the negative 39 is exactly the reciprocal or the multiplicative inverse of x to the 39th, or 1 over x to the 39. You can also remember that pattern, that if we have negative exponents in the numerator, they're going to go to the denominator. Great. That's the solution to part B. Let's look at part C now. Part C, now we could solve maybe a couple different ways, and maybe some people would want or be inclined to solve this problem by distributing a 3, or this power of 3 to the 2 and the power of 3 to the x. And that's totally fine. That might even be a better way to solve this problem. However, I want to practice using the quotient property of exponents on this problem to see how it might help us in the future in a different application. So we have 2x divided by 2x cubed. The first thing I want to do is I'm going to put parentheses and the first power around 2x in my numerator. And hopefully this helps you guide your thinking on how we could use the quotient property of exponents for this problem. So notice here that we have this product to a power and this product to a power. Well, this actually still works with the quotient property of exponents. We could say that this is the same as 2x raised to the 1 minus 3 power. Again, all we're doing is we're seeing a quotient of powers, a quotient of something to the first power and something to the third power. So what we're going to do is we're going to subtract those powers, the numerator power 1 from the denominator power, and the denominator power 3. Anyways, we can solve this by rewriting this as 2x to the negative 2. Again, at this point, you might be wanting to distribute, and that would be totally fine. But first, I'm going to move this product into my denominator, or this power into my denominator, by writing this as 1 over 2x squared. And then finally, I'm going to use that distributive property to say that this is the same as 1 over 2 squared times x squared, or 1 over 4x squared. Great, and that'll be our solution there. This problem will do with the last property we haven't discussed, which is the expanded distributive property of exponents. Now, as we discuss this, remember the expanded distributive property of exponents is really just kind of an extension of the distributive property of exponents. It's nothing new, it just has rewritten the distributive property to handle quotients. So let's look at these problems here. What does it say? Simplify the expressions below. Answers should be written with positive exponents only. And notice in all these problems here in A, B, and C, we have quotients raised to powers, or we have powers of quotients. And that's when we think about this expanded distributive property, or just the distributive property with quotients. So let's do this first example here. Before we do the first example, let's remind ourselves what the distributive property says and maybe what the expanded distributive property says. So the distributive property says, again, if I have x, y to the n power, this is the same as x to the n, y to the n. And the expanded distributive property says if I have x divided by y to the n power, this is the same as x to the n divided by y to the n. And we have a special stipulation in this case that y cannot be 0. Why is that? Well, again, because we can't divide by a 0. Anyways, we can apply the distributive property, the expanded distributive property to these quotients here. We have 2/3, or the fourth power of 2/3. How can we do this? Well, what we can say then is that we can distribute this fourth power to my numerator and to my denominator. So I can distribute the fourth power to my 2 and divide that by the fourth power of 3. So in these cases here, if you look at this second set, or the second formula with the green dot that I just pointed there, x is kind of like 2, 3 is like y, and 4 is like n. In any case, we can solve this by simplifying 2 to the fourth and 3 to the fourth. 2 squared is 4, and we're doing 4 times 4 then, so this is 16. 3 squared is 9, and 9 times 9 is 81. So we have a solution there, 16/81. And that'll be good for that one. Let's look at part B. Part B, we have the 8th power of the quotient of x squared and y. So what we're going to do here, we'll apply the distributive property to this quotient to say that this 8th power can distribute both to my x squared and to my y. When I do that, notice that I'm going to have x squared to the 8th power in my numerator divided by y to the 8th power in my denominator. So I'm going to have to use the power property of exponents to simplify my numerator. I can say that that's x to the 2 times 8 power divided by y to the 8th power, or x to the 16 divided by y to the 8th. And then you see we have our solution. Let's look at C. Now C is a little bit more complicated because not only are we taking a power of a quotient, but inside of our quotient we actually have a product in our numerator. So as we talk about this, remember that the expanded distributive property is just the distributive property for one case of a quotient. This is still can be considered, if you think about this, as s times t times 1 over r cubed. And we could use the distributive property for such a product. I'm going to rewrite this in one other way that some people would maybe like to look at this problem. They could rewrite this as r to the negative 3 st squared. And in this case, it's almost easier to see how the distributive property would make sense because it's just a simple bring the 2 to the negative third power of r to the s and to the t. In any case, we can rewrite this as r to the negative 3 squared, s squared, t squared. Using the power property of exponents, we can write that as r to the negative 3 times 2, s squared, t squared. Finally, r to the negative 6, s squared, t squared. And because we like to have our answers written with positive exponents, we could rewrite this finally as s squared, t squared over r to the 6th. Again, this isn't the best way to do it. It's just one way that some people prefer, and maybe it guides your intuition on how all these problems are really just distributive problems. Even with quotients, we could write all these quotients with negative powers and just use the distributive property. You see how it's the same thing. Great. The last problem we'll do in this video has to do with all properties of exponents, and where we have to kind of know what properties to use in which cases. So here's the 6 problems we'll do. I've written them up. Let's get started. Part A, x squared cubed times x to the 7th to the 4th. So what do we see here? Well, notice that we see powers of powers, right here, powers of powers, and we also see products of powers. We're multiplying this base to some power and this base to some power. So we're going to use the power property of exponents and also the product property of exponents, at very least, maybe more, we'll see. So the first step we'll do again is let's use the power property to simplify these powers of powers. So I could rewrite this as x to the 2 times 3 power times x to the 7 times 4 power. And the reason I can do that again is because of the power property of exponents. Because I'm going to write that a lot, I'm going to say it's the prop of exponents. In any case, we can continue solving this problem by simplifying the exponents now. So we have x to the 6th times x to the 28th. How could we combine x to the 6th times x to the 28th? Well, we could combine that using the product property of exponents. So notice that we have a product of powers, so we're going to use the product property of exponents to make that expression more simple. The last step here is to simplify x to the 6th plus 28. and that's just going to be x to the 34. And that'll be our solution for part A. Part B. Part B says the second power of 7y times the 30th power of y cubed. So what do we have here? Well, notice that we have a power of a product, so we use the distributive property. We have powers of powers, so you will use the power property. And we also have these y's raised to powers that will eventually multiply, so we're going to have a product of powers too. So I can identify at least 3 properties that we will for sure use in this problem. Let's go ahead and begin this problem by simplifying. And the first steps I would do here is to distribute the second power to the 7 into the y, and to simplify this power of a power, the 30th power of y cubed. So notice that I could rewrite this as 7 squared times y squared times y raised to the 3 times 30 power. Now I did 2 things there. I used both the distributive property of exponents and also the power property of exponents. Okay, great. So how can I simplify it now further? Well, I could say that 7 squared is just 49. I have a y squared times a y to the 90th power. See now that I could simplify using the product property of exponents to say that this is 49 times y to the 2 plus 90 power. And we can do this using the product property of exponents. So, again, we had a product of powers, so we use the product property of exponents. The last thing to solve this problem is just to say that this is 49y to the 92 power. Part C. 2a times the square of 2b times the cube of 2ab. So what are we going to do here? What properties might we use? We're going to end up using at least a distributive property because we have a product raised to a power. We have another product raised to a power. So we'll start with the distributive property. We can say that this is 2a times 2 squared times b squared times 2 cubed times a cubed times b cubed. And how did we do that? Again, the distributive property of exponents. Okay, what can we do next? Well, notice that this is just a big product, right? We have these parentheses, these grouping symbols that tell us what we should multiply first or second or things like this. But we know that multiplication is associative and commutative, so this order doesn't matter. And this we can rearrange and do these multiplications in any way we choose. And in particular, advantageous way to look at this problem is to look at this as 2 times 2 squared times 2 cubed times a cubed times b squared times b cubed. Now when I do this, this is advantageous because now hopefully you can see we have the product of powers. So by using the product of power rule, we'll be able to say that 2 times 2 squared times 2 cubed is just 2 raised to the 1 plus 2 plus 3. And so on and so forth with a and b. So we could say this is 2 to the 1 plus 2 plus 3 times a to the 1 plus 3 times b to the 2 plus 3. And we could do that by the product property of exponents. At this stage, we'll just need to simplify the exponents and then eventually the power of 2. So we have 2 to the 6th, a to the 4th, b to the 5th. To simplify this, we need to know what 2 to the 6th is. Well, 2 times 2 is 4, times 2 again is 8, times 2 again is 16, times 2 again is 32, and times 2 a sixth time is 64. So we can write this as 64, a to the 4th, b to the 5th. Part D, let's look at the problem together. It says the fifth power of k cubed times k divided by the second power of the second power of k cubed. So how can we do this problem, or what properties of exponents are we probably going to use? Notice that we have powers of powers of powers in the denominator, and in the numerator we have powers of powers and product of powers. So we're going to use the power property of exponents a few times and the product property of exponents at least once. Then notice that we're going to have a division or a quotient, so we could use the quotient property of exponents probably as our last step. And then if we even have something where we get a negative exponent by some manner, we'll have to use the negative exponent property of exponents as well. So let's go ahead and discuss this and start by solving this by simplifying some of these powers. So I'm going to simplify this first power, the fifth power of k cubed, by saying that is just k to the 3 times 5. I still have that multiplication of k in the numerator. In the denominator, well, notice that I have k cubed squared squared. So I'm going to start with these brackets, and I can say that k cubed squared is k to the 6th, or k to the 3 times 2 squared. How can we do this again? Well, we use the power property of exponents. What next? Well, next we could say that we'd simplify some of these exponents. Say that this is k to the 15 times k over k to the 6 squared. Notice I changed these brackets to parentheses. That doesn't matter as long as I didn't change the position of the grouping symbol. From this point, let's move up on over here. What can we simplify that numerator to be? Well, notice that this numerator, we have a product of powers. So we could say that that is the same as adding those exponents together. So we have k to the 15 times k. We can rewrite that as k to the 15 plus 1 power. Now we're dividing that by a power of a power. So we can say that this is k to the 6 times 2 power. How can we do that? Well, on the top we did the product property of exponents, and in the in the denominator we did the power property of exponents once more. Okay, what can we do to simplify? Let's simplify these exponents. We have k to the 16th power divided by k to the 12th power. How can we simplify this? Well, we can simplify this using the quotient property of exponents and say that the quotient of k to the 16 and k to the 12 is the same as k raised to the difference of their powers, or k raised to 16 minus 12. That was by the quotient property of exponents. And the last step we'll need to do here is a little simplification to say that 16 minus 12 is 4, and our solution then is k to the 4th power. Part E. We have the negative third power of the product x, y, and z squared times the product of x to the 20th, y to the 21st, and z squared. So what are we going to do here? What properties do we see that we're probably going to use? Well, notice that we have a product raised to a power, and so we're going to have to use the distributive property of exponents. Additionally, this is a negative power, so we're going to have to use the negative exponent property. Notice that we're going to have x squared to the negative 3, so we're going to use the power property because we're going to have x squared to the negative 3. Additionally, we have powers of x here, powers of y here, and powers of z here that we're eventually going to need to combine either by the product property of exponents or by the quotient property of exponents. So we're going to use a lot of properties here. Let's see what we can do. I'm going to start by distributing this negative 3 power to all the parts of this product here. So notice I can rewrite this as x to the negative 3, y to the negative 3, z squared to the negative 3. And I'm going to drop these parentheses because I know that order does not matter when multiplying. So how did I do that again? That was the distributive property of exponents. And what can we do next? Well, what we can do next is we can simplify this power of a power. We could say that this is the same, and I'm also going to rearrange these variables or these parts of my product at the same time. I'm going to arrange this so I have my x's near each other. So I have x to the negative 3 times x to the 20. Then I'm going to write times y to the negative 3 times y to the 21 times, now I know z squared to the negative 3. What could I rewrite that as? I could rewrite that as z to the 2 times negative 3, using, again, the power property of exponents. And finally, I'll have this z squared that I haven't included yet. So what did I do there? I used the power property of exponents. Fantastic. What can I do at this point? Well, notice that I have all these products of powers. Boom, boom, and boom. Let's combine those three products. I guess we'll have to do a little bit first with the z's before we can combine them. But notice we'll have here x to the negative 3 plus 20, y to the negative 3 plus 21. And I'll write this here. The in-between step, we know that 2 to the negative 3 is negative 6. So this would be z to the negative 6 plus 2. Okay, so how did we do that? We did that by the product property of exponents. At this stage, we need to simplify these exponents. Negative 3 plus 20 is 17, so I have x to the 17. Negative 3 plus 21 is 18. And negative 6 plus 2 is negative 4. Now we're not quite done yet because we need to rewrite this with only positive exponents. So how can we do that? We can use the negative exponent property to put z into the denominator. So I guess I'll just bring this guy right over here. For our solution, we have that this is equal to x to the 17, y to the 18, over z to the 4th. And it wasn't clear how we could do that. That's just the negative exponent property. Great. Part F. So this is a little bit more complicated expression than the previous one, so I won't begin by saying all the properties that we'll use. So notice that I could rewrite this as 2x squared y to the 4th, 2x to the negative 1, y to the negative 2 squared over 2xy times 2xy. And how could I do that? I just basically moved this 2xy in my numerator to my denominator by the negative exponent property. The negative exponent property. At this point, I'm going to choose to, in my numerator at least, distribute the 4th power to this product and the 2nd power to this product. And then the denominator, I'm just going to multiply these numbers. I know that this is 2xy, this product all squared. Either way, I can multiply these out. So what I do here, well, I'm going to distribute the 4th power to my 2. So I have 2 to the 4th power. I have x squared to the 4th power. I have y to the 4th power. Then I have 2 to the 2nd power. I'm distributing this 2 over here. Then I have x to the negative 1 to the 2nd power. And then I have y to the negative 2 to the 2nd power. And in my denominator, well, notice that multiplication is associative and commutative, so I could multiply these in any order I choose. So I'm going to multiply 2 and 2 to get 4, multiply x and x to get x squared, multiply y and y to get y squared. So again, what did I do in the numerator? Well, in the numerator, I just used the distributive property of exponents. And in the denominator, I just did some old-fashioned multiplication. Where can we go next with this? Well, notice that we have powers of powers we can simplify, and eventually we're going to have to do some products of powers as well. So from this step, let's bring it up here and say what we have. We can also do a couple simplifications. For example, we have 2 to the 4th and 2 squared. Let's put those next to each other, and we say that's 2 to the 4th times 2 squared times x squared to the 4th. That's x to the 2 times 4 power. I'm going to put that next to x to the negative 1 times 2 by, again, using the power property of exponents. And then multiplying that with y to the 4th and y to the negative 2 times 2, which will eventually be negative 4. So, and in the denominator, what can I do? Not much. I'm going to leave it as just 4 x squared y squared. How could I do that? I did that using the power property of exponents. The power property of exponents. Alright, next step, what can I do? Well, let's use the product property to make a lot of these things a little bit simpler. So for example, 2 to the 4, 4 times 2 squared is 2 to the 4 plus 2. X to the 2 times 4 is x to the 8. We have x to negative 2. We have y to 4, y to a negative 4. Still divided by 4x squared y squared. Only thing we did there was the product property of exponents on just my 2 to the 4 plus 2. And now I'm going to use it again on this x8 and x to the negative 2, y to the 4th and y to the negative 4. Notice that I have 2 to the 6th then times x to the 8 minus or plus negative 2, y to the 4 plus negative 4. And we're dividing this all by 4x squared y squared. At this stage, we could say that 2 to the 6th power, well, this is just equal to 64. So 64. 8 plus negative 2 is just 6, so I have x to the 6th. 4 plus negative 4 is 0, so I have y to the 0. Divided by 4x squared y squared. How did I do, or what steps did I do here? Ooh, I forgot to say, we use the product property of exponents here. And what properties do we use in that next step? Nothing, we just simplify exponents. So we need to do a little bit more. I'm going to erase this side of our board to continue our problem. So, what can we say at this step? We're getting really close. Well, notice a couple of things. What is any number to the 0 power? Any number to the 0 power is 1. So this y to the 0 power is just equal to 1. So that's kind of going to disappear. So I'm not even going to write that in this next stage. What do I have left then? I'm just going to rewrite my problem so I know what I'm working with. I'm working with 64 x to the 6th divided by 4 x squared y squared. How can I simplify a problem like this? Well, I can simplify a problem like this is to look at the quotients of things that have the same base and also just look at quotients of numbers. So in this case, we're going to split this up. We could split this fraction up into all of its number parts, its variable parts, or into a product rather of fractions with numbers, fractions with x's, and fractions with y's. So we write this notice as 64 divided by 4 times x to the 6th divided by x squared times 1 over y squared. Notice we could use a little bit of simplification. 64 divided by 4, that's 16. X to the 6th divided by x squared is x to the 6 minus 2. And we still have this times y over, or 1 over y squared. How did we do this? We did the quotient property of exponents. And at this step, I can say that this is 16 x to the 4th over y squared. And that'll be our final answer.